What goes up must come down. This is an observation here on the ground in reality, which is associated exclusively with the theory of a spinning globe Earth and its mysterious counterpart, gravity. People assume that gravity is a fact because their pen falls to the ground if they let go of it. Gravity must be correct because apples never float up from trees when they become ripe. The theory of gravity states that the mass of the world is warping space-time, which causes a sort of surface tension in the vacuum of space. Right off the bat, there are some inherent problems to this, which I'll take a moment to describe. If gravity is caused by the void of space pushing down in towards the center of the Earth, where's the equal and opposite of that force to allow for the push to bear force? How can a void push down upon anything with any force whatsoever? In order for the void of space to push anything in towards the Earth, the void of space would need to have some sort of substance or resistance or density or back pressure on the opposite end of the push in order to exert a force in towards the ground. Since the opposite end of this alleged push is the infinite void of space in the heliocentric model, the theory of gravity is disproven very simply. For one, a substance with a mass of zero cannot push a massive object with any force. For example, if you were hit by a truck that was traveling 100 miles an hour, but the truck weighed exactly zero point 0 pounds, then the force exerted on you at impact would be zero. And in fact, no matter how fast that truck was going, the force upon you would still be zero, much like a 10,000 pound truck traveling at 0 miles per hour will also exert a force of zero. The other problem with the conventional explanation of gravity is the simple fact that our atmosphere exists adjacent to the infinite void of space. Even the thin air, small distant particles miles above the ground, directly adjacent to the vacuum of space, are stuck in place by this mysterious force of gravity, which has yet to be proven or even detected in reality. If the total weight of space, say 1,000,000 miles in all directions from the spherical edge of the atmosphere, is essentially zero, then how is it possible for a combined force of zero to compel objects near the Earth to be stuck to it, in spite of the powerful centrifugal forces, for example, exerted outward from the face of the Earth at the equator, with real mass and real velocity behind it in theory, of course? This theoretical centrifugal force would be most prevalent at the equator, where an observer would be standing perpendicular to the axis and allegedly spinning 1,037.5 miles per hour eastward, well above the speed of sound, I would add. On the other hand, this theoretical centrifugal force wouldn't exist at all at the North Pole, where the Earth is allegedly spinning half the speed as the hour hand on a 12-hour clock, discernibly not spinning at all. Yet for some reason, the overwhelming force of gravity at the equator is apparently on holiday for any observer near the North Pole, since objects weigh practically the same at the two locations on the globe, which would be so fundamentally different in terms of velocity and angle towards the axis of rotation when comparing the pole to the equator, yet the two places in reality are very similar in those terms. This is a major problem in the logic of heliocentrism that is never truly answered or even considered. And so volumes of mathematics have been hammered out to show how all this works out in theory on a spinning globe, back engineering mathematics to align with the presupposition that the Earth is a spinning globe in the first place, and therefore weight is not affected by the disparate centrifugal forces at the equator versus the North Pole. To take this even further, unrelated bodies in the heavens are supposedly tethered to one another by the mysterious theory of gravity. Our world allegedly orbits the sun due to this mysterious force of undetectable, undemonstrable, unfalsifiable theory of gravity, without any trace of its existence to be found in spite of decades of searching for it. You would think such an overwhelming force that keeps our planet in a curvilinear orbit around the sun, without any explanation for the necessary centripetal force other than gravity, and yet the moon apparently doesn't experience the sun's gravity whatsoever. And by the way, how can the Earth and moon be tethered to one another by nothing more than a void of space? The last time I checked, a chain is only as strong as its weakest link. So if your entire chain is made of zero links, then you really don't have a chain, nor do you have a viable theory.
I mean, gravity, of course, is something that well, many people have already thought about it. It's something that we see every day, and it's not like it's not existent in our every life. But what I mean by that it's an illusion is that one would eventually like to know where it comes from, an explanation. Up to now, we have, well, descriptions. I mean, Newton, of course, is the one famous for first writing down a theory of gravity. And he could describe why apples fall and why the moon goes around the Earth using the same basic equation for gravity. But he described it. He had to assume that gravity was there, and then had to write down a law that described that when two masses are at a certain distance, how they attract each other. But he was also not very happy with the fact that he should just, well, assume that these things, these objects, attract each other and without even anything in between. So if there are two masses in empty space, there's nothing that really happens between them, but still they're attracting each other. And he thought that was kind of mysterious, and that it was something he would have liked to explain in a better way. So later came Einstein, and Einstein, with his theory of relativity, eventually realized that also gravity has to be described in a different way. And it took him quite some years, but then eventually he wrote down a theory where he thought about space and time together. And then his explanation of what gravity would be is that there's masses which curve space and time. And then the motion of planets and of the Earth around the Moon, or the Moon around the Earth, is then described by thinking about moving in this curved space-time and how then objects are well, making their orbits. And the reason they go around then in circles is that that space and time itself is curved, in the sense that things don't move in straight lines anymore, they go around. So that was his explanation, but he had to write down an equation for it, which again assumed that gravity is there, because he basically wrote down that the matter curves the space-time. So in a certain way, that's still a description, or what I should say is, well, one would like to understand again why this description sort of, well, how you can understand it from a more basic point of view. So what I've done in my paper is try to start from a, well, from a point of view where you don't assume gravity to be there. You would like to explain it by seeing how you can derive it from a more microscopic set of equations where gravity itself is not assumed, but then just follows from a certain logical reasoning. If you think about particles, very tiny particles, then it turns out that things like positions and velocities are not very precisely defined. You have to take into account the fact that there's an uncertainty in when we look at something. We may influence the measurement, but we may also just, there's a fundamental limit on how precise you can understand the position or the velocity of a particle. They cannot be not both described infinitely precise. So taking gravity into account then gives us a bit of a problem, because then we have to talk about space-time, and then these quantum uncertainties gives us another way of looking at space-time at the short distances. So this led to problems, and string theory is another way of also looking at gravity and quantum mechanics, which I've been working on quite a bit. So people have studied the problem of quantum mechanics and gravity from various perspectives, from string theory, but also by thinking, for instance, about black holes, what happens with black holes. And I've taken some of the things we've learned about it and seen that there is some explanation of maybe where gravity then comes from those new way of thinking about quantum mechanics and gravity together. So if you then start trying to explain where it comes from, it has to do with the fact that there's, at a microscopic scale, a certain information about how you describe this, which we don't see ourselves. We forget about that. And it turns out that if you take that into account in some appropriate way, that you can understand where gravity comes from. the theory that Einstein wrote down, when you apply it, for instance, to these black holes, you see that it starts resembling things that we call thermodynamics. That's a theory that describes how gases move when they give them a temperature, or when there is pressure, and you well, you can apply it in very many situations, but it's some way in which we describe how things happen at fairly large scales, in terms of not looking at the individual motion of the atoms and molecules, but by just thinking about these objects like temperature, pressure, and so on, which are what I call microscopic quantities. I mean, a temperature is something that is just an average of all of the motions, or the little collisions of atoms. Say, for instance, on my skin, if I think about what temperature I feel, it says something about the average energy that each of the molecules in the air is carrying. So temperature is not really a microscopic thing I can define. And so gravity is somewhat like that, in the sense that the equations that we currently use to describe gravity are basically obtained from averaging, or at least describing things at a much tinier scale, and then forgetting about certain details. So temperature, for instance, also forgets about how all of the individual molecules are moving. We don't have to keep track of that, but still we can describe quite well how gases move when we just talk about pressure and temperature, and even differences in pressure, for instance. Then if you have one room with one pressure and another room with lower pressure, you simply know that the gas will flow from one to the other. And these kind of differences is then necessary to get things moving. It's fun to think about things like gravity, and even, well, what I had in my paper, things like even the laws of Newton, because they do play a role in one's everyday life. But it's surprising that when I go and walk out the door and something like that, it's not like I immediately sort of think about these things in a different way. But for me, I think it's more important eventually what will be the implications for understanding not just gravity, but also what's happening in the universe. I mean, the gravity equations of Einstein are also used in describing the expansion of the universe. The Big Bang theory are all based on these same equations. What I hope is that the ideas that we are now starting to develop for gravity can eventually sort of lead to possibly somewhat better or even more refined way of thinking about the early universe. And I think that will influence a little bit more my thinking than, yeah, I think as human beings we like to know where we come from and how the universe sort of developed into what it's now. And there I think eventually this will have some impact.
Must come down. This is an observation here on the ground in reality, which is associated exclusively with the theory of a spinning globe Earth and its mysterious counterpart, gravity. People assume that gravity is a fact because their pen falls to the ground if they let go of it. Gravity must be correct because apples never float up from trees when they become ripe. The theory of gravity states that the mass of the world is warping space-time, which causes a sort of surface tension in the vacuum of space. Right off the bat, there are some inherent problems to this, which I'll take a moment to describe. If gravity is caused by the void of space pushing down in towards the center of the Earth, where's the equal and opposite of that force to allow for the push to bear force? How can a void push down upon anything with any force whatsoever? In order for the void of space to push anything in towards the Earth, void of space would need to have some sort of substance or resistance or density or back pressure on the opposite end of the push in order to exert a force in towards the ground. Since the opposite end of this alleged push is the infinite void of space in the heliocentric model, the theory of gravity is disproven very simply. For one, a substance with a mass of 0 cannot push a massive object with any force. For example, if you were hit by a truck that was traveling 100 miles an hour, but the truck weighed